All right, welcome everybody. I'm Lucian Fogoros, and today we're talking about AI in process safety. And with us, our guest is Chris Togner, the Director of Offer Management at Schneider Electric. Welcome, Chris.
Hi, Lucian. Thanks for having me.
Sure. So, Schneider Electric's recent patent introducing AI to process safety is a groundbreaking step forward. It's exciting to see how AI is being leveraged to automate hazard analysis, improve hazard operation studies, and enhance functional safety, basically the boomable industry. As the Schneider Electric Director of Offer Management, you're right there at the forefront of advancements. Can you share your perspective on how this innovation reshapes the safety practices and its potential to transform the industry?
Yeah, I can. And I do want to be clear, and this is probably a little bit different than most announcements that we do in that we don't actually have a product yet, right? What we have is a patent, right? We know that there is a problem that needed to be solved, and it still needs to be solved. And process safety is not generally an area where people want to rush innovations, right? But we know that the use of AI should be very applicable. And so, we started doing this research, and we found a methodology to automate some of the process safety steps, in particular. The very beginning, when we do a hazard operability study or HAZOP, which the industry uses, and what we're really trying to do now is let the world know that we have this patent and see if we can, get people, interested in adopting this technology, how we could apply it to their standard work practices, because we do think it would make, the world a safer place.
Got it. Thank you. So this new patent, right, address the challenges in traditional safety practices and improve outcomes for manufacturing. How does it do that? Maybe
Well,
expand a little bit.
first of all, a little bit, there's different types of AI, right? And
Mhm.
what we're using is a reinforced learning model. And so, imagine that you have one of the inspirations was an AI that's called hide and go seek, right? So you have the children's game where you have, playing hide and go seek. And so you have one AI agent that's, the hider, and one AI agent is the seeker, right? And so every time the seeker finds the hider, they both learn, they change their tactics, they adapt, and they run through, numerous, iterations of this. And so what we've done with our reinforced learning model is we've basically have one AI agent that's trying to blow a plant up, and we have another AI agent that's trying to keep the plant from blowing up, right? And so after they run through however many iterations are needed of these games, for instance, with generative AI, you have to load some type of rules into it for it to be able to work, right? It has to generate things, and it generates the things that it doesn't know. With reinforced learning, it doesn't have to know anything. It just tries random things, and then it gets a reward based off how successful the thing that they tried are. So after these two agents run through thousands of iterations, it's identified all of the risks that could go wrong in the process, and as well as identified all of the protection layers that could be put in place to mitigate those risks. So, your HAZOP's done and your layers of protection analysis are done.
Got it. So it sounds like, through this simulation, this AI can enhance the HAZOPs to go beyond what the humans can analyze, right? And uh, is it accurate to say that, or?
Oh, it's very accurate. Because one of the things, this is a very subjective process. I think we like to, pretend that it's a very objective process, but, I'm aware of, some very recent exercises where, multiple process safety experts, and I'm not talking about, layman experts, where we're brought in and given identical plant designs and asked to do HAZOPs on it. And the results that they brought in, were widely varied, right? Whereas, with using AI, it can be much more of an objective process. There will always be a need, to have a functionally safety competent person involved in this process, right? And I think that's probably maybe where some of the reluctance comes in, right? People think that, okay, if we go down this route, we're completely turning our hazard assessments over to this thing that we don't trust yet, right? But way I see, at least especially in the early phases of this, it's almost like a checkpoint, right? I think you can still do, your human assessments, and then compare the results that the human HAZOP does versus what the AI HAZOP can do, and then perhaps you find other you know things that needed to be accounted for that weren't accounted for. One of the things that the challenge is when we've brought this to several of our traditional manufacturers in our segments, they all see the need. Nobody doubts that this isn't a process, in need of improvement. So that there's interest there. But I think also nobody wants to be the first. But when you think of a big enterprise, right? Some of these, global operators, I mean, they may have 50 different operating facilities around the world. They are always in a HAZOP somewhere. Every unit is constant because you don't just do it at the beginning. You're supposed to come back and do a re-HAZOP every 3 years, 4 years, 5 years. And it's like we always bring in a bunch of highly paid people, and we have them for 3 weeks at a time. We ask the exact same questions and we get the exact same answers because these people are bringing their biases from the previous time they did into it. An AI tool is not going to have all these things, right? And it helps give new perspectives. The AI tool is not going to get tired, and it can help identify hazards that perhaps weren't there before. It can help standardization.
That's an interesting point, that perception and the background information a specialist in the area comes with it with a bias about it. I think there was another study on a different area in healthcare where they tested Gen AI versus doctors, and Gen AI was about 90% versus the 75% that Gen AI with the doctor because of the perception of the
Yeah.
people and the baggage of information they have on detecting, I think it was detecting cancer, what they did a study,
Mhm.
if I'm paraphrasing Peter Diamandis on that. But maybe in your conversations you have with the large customers, maybe expand a little bit on the role that you see in streamlining the entire safety cycle, life cycle from hazard identification to validation and safety mechanism, and maybe anything that jumped out of you, some direct operational efficiency comments there from the
We have
customers.
this patent already, and I can't give detail now, but we have a few other patents that are pending, right? That are all using
Mhm.
AI where we can expand this. The goal is to automate the safety life cycle.
Mhm.
Everybody's driving towards zero engineering, right? I mean, it's probably a goal that'll never be hit, but you start with that, you try to, remove as much, you know, non-value added work as you possibly can. And it's not that we're trying to, replace the humans with the machines. It's just there are growing needs in the world of energy needs. All plants are expanding, but the resource pools are shrinking, right? There's less people that are going into these fields. There's just less people, period. And a lot of these developing countries, their population demographics are, kind of an inverted pyramid. They have more people that are over 50 than they do that are under 20. So, we have to be able to figure out ways to do more with less people. It's just a fact. And the other thing is that people don't stay in one position for a company like they did in the past. It's been multiple times I've met with some of these customers recently, and they'll point to some guy sitting at the end of the table and say, this guy's been managing my safety systems for the last 25 years. He's about to retire, and I'm not going to be able to replace him, right? So the more that we can automate these processes, then the more that, we can keep the expertise, with the tools to augment the human, right? Use the
Mhm.
machine to help the human rather than the machine to replace the human. If we can automate the HAZOP and the LOPA process, it's not a great leap to say, well, from there we can take that to then automate your safety requirement specification. We can automate, a lot of your code generation. We can automate the testing and validation. All of these things, they require trust for the people to use them, but it ultimately will make them safer because you can do things that the humans just don't have the time to do.
Right. So I just want to make sure I caught this right. So if basically you apply this, I know it's just a patent, but applying this AI innovation, uh, basically you can help with align with global standards, right? And help manufacturer navigate through this regulatory environment. So that I get it right?
I think you've caught the essence of the question, right?
Right.
It's very easy to integrate what the standards are, and I think the standards are also going to evolve so that they account for the use of AI, right?
Mhm.
There's a growing idea that you're going to have to use software, whether it's AI or traditional software or not, to help augment the fact that we have these, diminishing resource pools. And so I know the safety standards are now starting to look at the use of software tools, and they should have a safety assessment that goes with them, just like we do with the hardware, controllers that go into a protection system.
Got it. Now, you've referenced some of your larger customers that you've got feedback from. Can you expand a little bit on the scalability of this innovation to small to mid size type of enterprises and how they may lack the infrastructure of large, compared to the largest industrial players? Can this help with that?
I think it definitely can. I mean, there's emerging segments, new energy that's coming online, and hydrogen, green hydrogen, blue hydrogen, nuclear SMRs, all these type things. The traditional chemical oil and gas customers, it's a very time-consuming task to do these things, but at least they have 30 to 40 years of practices that they can rely on, and they've pretty much standardized on it. It's practices that can be streamlined for sure, but still very time consuming. When you start going into hydrogen, I attended a couple of process safety hydrogen conferences last year. Uh, they're not as mature in their mindset. They don't have 30, 40 years of experience of doing these type things. And then I think that they could benefit from a tool that helps, streamline this process even more so than the people that have been doing it for 30, 40 years. Hydrogen has a lot of promise as a new energy source. But it's also very high risk. And, I think we all are aware of the Hindenburg, right? So now you're taking production, at least with an oil refinery, right? You have, very few of them around the world, and all of this risk is very centralized. And we start talking to some of these new energy concepts where we're decentralizing, we're moving this risk, out smaller production and more sites. You won't have the human resources to be able to do all these assessments on a broad scale like this, and they're going to need something, and they're going to need to use tools like artificial intelligence to help do these things.
Got it. So it sounds like, okay, you're taking the experience from chemical and process, some of the boom industry, and could be leveraging in new emerging markets like hydrogens and perhaps other renewable and perhaps even transportation, right? Can you see any other beyond this industry that can you see this protocol or this patent being leveraged in other industries?
Well, the transportation is going to require, everything's moving towards electrification, right?
Hmm.
And, you kind of mentioned a couple of times boom, right? So, as we go into electrification, we're moving a little bit from things that go boom to things that go zap. And, what that creates whole new challenges, right? And those are things that, maybe aren't quite as well understood and could benefit from the use of AI. There's going to be huge investments in electrification of the world, in the coming years, just because, we have to satisfy all of the goals that we have for electric cars and AI and data centers. I actually read a quote from Elon Musk just a couple of days ago that he said that if 1 in 10 Americans write a single 100-word email in ChatGPT, a week, I think that is something like 121 gigawatts of power that's required to do that. And that's equivalent to the total draw for Washington, D.C. for how much they do, right? So we don't have the power structure in the world right now to be able to do that. So there's going to be a huge ramp up in construction, I think, and investments in the electrical grid. And, we're going to need tools that help people do that safely.
Yes, thank you, Chris, for sharing the insights. And if you're in the audience, feel free to leverage the hashtag to ask the question. We'll get Chris and his team to answer them. Or if you're at the ARC forum, there's several options there to either join. I think there's a breakfast set up there. You can learn more on Tuesday morning, and there's a press conference as well. Uh, any parting way questions, Chris?
Something we're very excited about. This is a new frontier. With Schneider Electric, in particular, our Triconics product line. We've kind of always been first to the market with any innovation when it comes to safety, and we were the first to have a patent with artificial intelligence. But it's not just enough to have the patent. We want to have people come forward to us and express an interest and work with us and bringing something to the market that's really going to help them be more safe and more profitable.
Thank you, and look forward to learn more and new use cases for it. Looking forward to learn more during the ARC forum.
Well, thanks for the opportunity to discuss. I appreciate it.